Hi, good morning. In this video, we are going to discuss about one of my case study titled Formation of Functional Nanofibers Electrospun Polyurethane Containing Grapes for Wound Healing Applications. The abstract of my study was in this study, I have used the electrospinning technique for fabricating the novel scaffold based on PU containing grapes for wound healing applications. It was shown in my study that the novel composition showed better physiochemical properties suitable for the wound healing applications. First, we will see about the what is wound dressings. Wound dressings play important role in managing many types of wounds such as traumatic wound, thermal wound, chronic wound. The materials utilized in treating the wound dressings are biological, synthetic, and biological synthetic. In that, the elements used for the making the commercial wound dressings are allograft and autograft. However, they possess some disadvantages such as high antigenicity, poor adhesiveness, and risks of cross contaminations, which make them limited in the clinical applications. Hence, there is a need for alternative approach for the remodeling the damaged tissue. Next, we will see about the electrospinning technique. In manufacturing side, there are a number of techniques for fabricating these scaffolds. However, I have used electrospinning technique for the fabricating the scaffold because it can able to produce nanofibers from the polymer solution with the help of high voltage. The nanofibers possess advantages like high surface to area and porous structure, which help the cell to adhere on the surface and helps in the tissue remodeling. Further, electrospinning is a versatile and cost-effective technique. So I used the electrospinning technique for my research. Next, materials. I have selected the polyurethane for the fabricating the scaffold. Polyurethane is one of the commonly used polymers in making dressing materials in the form of foams, minerals, films for wound applications. Further, the polyurethane is easily available at low cost. Further, it can be easily processable at any organic solvents. Next material used for grape. I have selected grapes for my study. Why I have selected grape means it possesses a number of biotic constituents such as sugars, organic solvents, phenolic compounds, nitrogen compounds, aromatic components, minerals, and pectic substances. These biotic constitutions helps in providing the biological properties such as antioxidant, anti-cancer, antimicrobial, and anti-inflammation activity properties. Next, for electrospinning technique, we have to prepare the polymer solution. Here, the polymer solution is prepared for the 9-wet fraction. Similarly, we have to mix the grape extract into PU. For grape extract, also the solution was prepared at the 9-wet fraction. In terms of volume fraction, I have mixed the grapes into PU at the weight fraction 8 is to 2. Finally, it was transferred to the electrospinning technique, and finally, the scaffold was fabricated. Next, after fabrication, it was sent to various physicochemical characteristics such as scanning electron microscopy, Fourier transform infrared spectroscopy analysis, quantum measurements, thermogravimetric analysis, atomic force microscopy. Next, semi-investigation used to study the fiber morphology of the scaffold. In this study, the addition of grapes reduced the fiber diameter PU. PU showed the fiber diameter of 890. PU grapes showed fiber diameter of 730 nm. It was clearly showed in the literature that the smaller diameter will be favorable for the new tissue growth. Next, FT analysis. FT analysis used to study whether we added the grape in PU or not. Key peaks in the PU are NH, CH, CO groups. The same groups was available in the PU nanocomposites. However, the intensity of the PU grapes was increased compared to the PU, which clearly indicates the presence of grapes in the PU membrane. Next, current angle measurements. Current angle measurements used to predict the wettability of the scaffolds. The current angle of PU was found to be 100, while PU grapes showed the wettability of 860 degree respectively, which clearly indicates the hydrophobic nature of the PU nanocomposites. It was clearly shown in the literature that the improved wettability of the scaffold will be favorable for the fibrous cell adhesion and proliferation. Next, thermostability. Thermostability is used to analyze the initial degradation temperature of the nanocomposites. It was clearly shown that the initial degradation of the P nanocomposites was higher compared to the PU. PU showed the initial degradation temperature of 270 degrees Celsius. However, PU grapes showed the initial degradation temperature of 289 degrees Celsius, which clearly indicates the improved thermostability of the PU membrane. The corresponding TGI curve was shown. The blue color corresponds to the PU grapes and the red color corresponds to the PU. There was a deviation in the blue color compared to the red color, which clearly indicates the improved thermostability of the PU grapes membrane. Next, surface roughness. Surface is an important parameter in the biomedical applications. PU showed the surface roughness of 313, while PU's grapes showed roughness of 469 nm respectively, which clearly indicates the roughest surface of the PU compost compared to the PU. It was clearly shown in the literature improved surface roughness of the composites will be suitable for the fibrous cell adhesion and proliferation. The corresponding images was shown, which clearly indicates that the PU surface showed the roughest surface compared to the PU. Thank you.